Good evening, students. Good evening, Rajeshwari, Sai, Swati. Mahendra. Sahiti. So, in this session, we are going to discuss in detail about the Lewis theory of acids and bases. So, coming to the Lewis theory of acids and bases, what is meant by an acid? So, according to Lewis, acid is a substance that accepts a pair of electrons and forms a coordination covalent bond. So, what is meant by an acid? Acid is a substance that accepts a pair of electrons and forms a coordination covalent bond. Moving to the base, Lewis base is a substance that donates a pair of electrons and forms a coordination covalent bond. So, base is a substance that donates a pair of electrons to the other substance and forms a coordination covalent bond. So, similarly, moving to the salt. What is meant by a salt? An addition product formed whenever an acid reacts with a base is called as the salt. Let us see what is meant by a neutralization reaction. So, coming to the neutralization reaction. So, the reaction which involves the formation of a coordination covalent bond between an acid and a base. So, let us consider one simple example. So, ammonia is having lone pair of electrons, so it can act as a Lewis base. Whereas BF3, boron trifluoride, is an electron deficient compound, so it will act as an acid. So, whenever ammonia is treated with boron trifluoride, then always it results in the formation of a coordination covalent bond between ammonia and boron trifluoride. So, this addition product is called as a salt. Clear? So, neutralization reaction always involves the formation of coordination covalent bond according to Lewis. Let us see the types of Lewis acids. So, coming to the types of Lewis acids, it includes various types of substances. So, in general, simple cations such as H plus, Na plus, Mg plus 2, Zn plus 2. So, all these substances will act as Lewis acids. Why? They are ready to accept electron pair. So in general, these electron deficient compounds are also known as electrophiles. At the same time, electron deficient compounds such as BF3, AlCl3 also will act as Lewis acids. On the other hand, the compounds in which the central metal atom can expand its octet can act as Lewis acids. ఏ కాంపౌండ్స్లో అయితే సెంట్రల్ మెటల్ ఆటమ్ అనేది దాని ఆక్టెక్ట్ కాన్ఫిగరేషన్ని ఎక్స్పాండ్ చేసుకోగలవు అవన్నీ లూయిస్ యాసిడ్స్. దట్ మీన్స్ దే కన్సిస్ట్ ఆఫ్ ఎంటీ డి ఆర్బిటాల్స్. సో బెస్ట్ ఎగ్జాంపుల్స్ ఆర్ సిలికాన్ టెట్రాఫ్లోరైడ్, silicon tetrachloride, tin tetrachloride. So they consist of, so let us see the configuration of silicon, that is 1s2, 2s2, 2p6, 3s2, 3p6, 3p2, and it consists of empty 3d orbital. So that's why it can act as Lewis acid. Clear? At the same time, if at all multiple bonds are present between the hetero atoms, then they also act as Lewis acids. Let us consider few examples like carbon dioxide, sulfur dioxide. So coming to the structure of carbon dioxide, here a double bond is present between the carbon and oxygen atom. With the result, what happens? Oxygen is more electronegative, so it attracts bond pair of electrons more towards itself. With the result, the central carbon atom gets the positive charge. With the result, it is electron deficient and hence it acts as Lewis acid. So these are the various types of Lewis acids. Clear? Okay, let us move on to the types of Lewis bases. So coming to the types of Lewis bases, especially simple anions, we can also call them as nucleophiles. They can act as Lewis bases. So good examples are Cl minus, F minus, OH minus, Cn minus, etc. So these simple anions are electron rich species and hence capable of donating electrons. So they will act as nucleophiles. ఏవైతే ఎలక్ట్రాన్ రిచ్ స్పీషీస్ ఉంటాయో అవి ఎలక్ట్రాన్స్ డొనేట్ చేయగలుగుతాయి. సో దే విల్ యాక్ట్ యాజ్ లూయిస్ బేసెస్. Next, the compounds containing at least one lone pair of electrons will act as Lewis bases. So, ఏ కాంపౌండ్స్లో అయితే జనరల్గా అట్లీస్ట్ వన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ ఉంటాయో అవి కూడా మనకి లూయిస్ బేసిస్గా బిహేవ్ చేస్తాయి. బెస్ట్ ఎగ్జాంపుల్స్ ఆర్ అమ్మోనియా, నైట్రోజన్ క్యారీస్ వన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్, water carries two lone pairs of electrons, alcohol carries two lone pair of electrons, amines, nitrogen carries one lone pair of electrons. So compounds containing at least one lone pair of electrons will act as Lewis base. Similarly, if a double bond is present between two carbon atoms. In that context, these electrons are readily available for the donation and hence these compounds also will act as Lewis bases. Best examples are ethylene, CH2 double bond CH2. These are the various types of Lewis bases. Coming to the merits of Lewis theory, especially it explains the behavior of wide variety of acids and bases. So mostly it explains the behavior of acids and bases. In particular, it explains the acidic nature of CO2, SO2 and also the acidic nature of electron deficient compounds. So particularly Lewis theory explains the acidic nature of CO2, SO2 and also electron deficient compounds like BF3, AlCl3. It also explains the basic nature of CaO. These are the merits of Lewis theory. Coming to the limitations, Lewis theory fails to explain the strength of acids and bases. So it fails to explain the strength of acids and bases. At the same time, in general, Lewis acid-base reaction involves the formation of coordination covalent bond between the acid and the base, which is against the general principle. So in general, acid-base reactions do not involve the formation of coordination covalent bond. Especially we know common acids such as HCl, H2SO4, etc. So these substances will not form coordination covalent bond. So it is also against Lewis principle. As Lewis neutralization reaction involves the formation of coordination covalent bond, so Lewis neutralization reaction is slow, but in general acid base reactions are very fast. So it is also against the Lewis concept. So in general, if we consider an acid base reaction, it is very fast, but Lewis acid base reactions are slow. So these are the few failures of Lewis theory of acids and bases. Now it's the time to discuss in detail about the multiple choice questions based upon the Lewis theory of acids and bases. Are you ready? Are you ready to answer? So coming to the first question, which of the following is a Lewis base? What is your answer? Very good. You try to answer. Which of the following is a Lewis base? Very good, Bhanu. Remaining students are also supposed to answer. S. Swati, Abhilash, Sriram. Very good. Yes, very good. So, base means it is capable of donating a lone pair of electrons. So, option D, ammonia is the right answer. Yes. Moving to the second question. In the reaction, NH3 plus BF3 gives rise to NH3 coordination covalent bond with BF3. So, BF3 acts as. So, what is the nature of BF3? What is the nature of BF3? Boron trifluoride will act as? Are you listening? Yes. In this particular reaction, what is the nature of BF3? You try to answer. Swati, Bhanu. Rajeshwari. Kiran Babu, you try to answer. Tilak. Yes. Bhanu, you are correct. Sriram. Yes. Sahiti, at once check your answer. Sriram, you gave two options. Which one is correct? Abhilash, very good. Yes. Here BF3 is acting as an acid. So option A is the right answer. Very good, Sriram. Next, let us move on to the third question. Be careful while answering the question. These questions are very simple. Simple questions కొంచెం జాగ్రత్తగా follow అవ్వండి. Which acts as Lewis base in the reaction? So PH3 plus BF3 gives rise to PH3BF3. So in this reaction, which compound is behaving as Lewis base? Tilak, very good. Rajeshwari, at once check your answer. Tilak, very good. Banu, right answer. Rama, Durga, very good. Swati, good. So you just observe the salt. Always a coordination covalent bond is formed from base to an acid. So what is the nature of PH3 here? PH3 is acting as Lewis base. Very good, Abhilash. So option B is the right answer. So PH3 is the Lewis base. Clear? Yes. Let us move on to the fourth question. Very simple questions. You at once think and answer. Okay. What is the fourth question? Lewis acid. Option A accepts protons. Option B accept a pair of electrons. Donates protons. Donate a pair of electrons. What is your answer? Tell me, what is the nature of Lewis acid? Yes, Banu, Tilak, very good. Durga, Kiran Babu, very good. Sahiti. Aditya, at once you check your answer. Abhilash, very good. Swati, very good. Sriram, very good. Sujit, very good. So acid is a substance that accepts a pair of electrons. So option B is the right answer. Clear? Here we are discussing about the Lewis concept, isn't it? Moving to the fifth question. Are you ready? So electrophiles are. So what is the nature of the electrophile? How they will act? Option A, Lewis bases. B, Lewis acids. C, Bronsted acids. D, Bronsted bases. What is your answer? Very good, Tilak. Sriram. Swati, at once check your answer. Abhilash, check your answer. Sahiti, very good. Kiran Babu, check your answer. Very good. Very good. So, definitely electrophiles means they are electron deficient compounds. That means they are ready to accept the pair of electrons. So, they will act as Lewis acids. So, option B is the right answer. Everyone gave the right answer. Very good. Sujit, very good. Coming to the sixth question. Central metal ion in the complex acts as. Options. Option A, Lewis base. Option B, Lewis acid. C, Bronsted acid. D, Arrhenius acid. So, I will give one simple explanation. AgNH3 twice plus it is a complex ion. So, in this complex ion, silver is the metal. So, you are supposed to answer central metal ion in the complex acts as. How it will behave? What is your answer? Very good. Very good, Swati. What happened to the remaining students? Yes, Banu. Very good, Rajeshwari. Yes. Sriram. Abhilash. Very good. So, undoubtedly, ammonia is a Lewis base. And hence, central metal atom will act as a Lewis acid. So, option B is the right answer. Very good. Moving to the seventh question, which is not a Lewis base? Be careful while answering. Which is not a Lewis base? Not a Lewis base means not a Lewis base. You are supposed to identify which of the following is a Lewis acid. Very good, Banu. Sriram, very good. Aditya, very good. Tilak, Durga, Sahiti, very good. Sujit, very good. Kiran, Abhilash, very good. So, Cn minus, H2O, Cl minus, all these are Lewis bases. Option A, silver is the Lewis acid. So, option A is the right answer. Let us move on to the next question. Lewis base is. So, you have to identify which of the following is a Lewis base. Which of the following is a Lewis base? Lewis base. Sriram, very good. Aditya, at once check your option. Durga. Abhilash, very good. Tilak, very good. You check the given options carefully. Kiran, very good. So, undoubtedly, option C, ammonia is a Lewis base. Yes, very good, Sahiti. Swati, check your answer. Moving to the eighth question, which is not a Lewis acid. Not a Lewis acid means you are supposed to identify Lewis base. So, which of the following is a Lewis base? Yes, Swati, try to answer the next question. Sriram, very good. You try to answer as early as possible. Yes, Abhilash, very good. Kiran, very good. Banu, very good. Banu, at once check your answer. Which of the following is a Lewis base? Not a Lewis acid means you have to identify which one is the Lewis base. Kiran, very good. Banu, check your answer. Aditya, very good. Sahiti, very good. Which of the following is a Lewis base? No. Banu, you are giving the wrong answer. Tilak, very good. Rajeshwari, very good. Swati, very good. Lewis base means it is capable of donating a pair of electrons. Water is a Lewis base. Clear, Banu? Yes, very good. Moving to the next question. The weakest acid among the following is. All the given options are hydrohalogenic acids. So you are supposed to identify the weakest acid among the following. Weakest acid among the following. Sriram, at once check your option. Yesterday I have explained the acidic nature of hydrohalogenic acids. The anion with large size is the strongest acid. So you have to identify the halogen with small size. Very good, Kiran Babu. Very good. You are supposed to identify the weakest acid. Aditya, check your answer. Rajeshwari, very good. Durga, very nice. Swati, very good. Yes, option D, HF is the weakest acid. It is having very small size and hence the bond between the hydrogen and fluorine is strong. So it will not readily donate the proton. So HF is the weakest acid. Clear? Moving to the 10th option. Which of the following molecule is not a Lewis base? Not a Lewis base means you have to identify Lewis acid. What is your answer? Which of the following is a Lewis acid? Yes, Tilak, very good. Sriram, very good. Abhilash. Rama Durga, very good. Sujit, very good. Aditya, very good. So option B, BF3 is the Lewis acid, whereas the remaining species will act as Lewis bases. Now let us move on to the next question. S. Which of the following is not a Lewis acid? Not a Lewis acid means you have to identify Lewis base. You think carefully and then answer. Now you try to answer 11th question. Which of the following is not a Lewis acid? That means you have to identify Lewis base. So what is the nature of the Lewis base? It donates a pair of electrons. Be careful while answering. Ramadurga, very good. No. Abhilash, Sahiti. Aditya, very good. Swati, check your answer. Tilak, very good. Kiran, very good. Swati, check your answer. Capable of donating a pair of electrons. That means we have to identify a substance in which an atom consists of lone pair of electrons. So option D is the right answer. Clear? Very good, Rajeshwari. Let us move on to the 12th question. Example of Lewis acid is. So identify which of the following is a Lewis acid. You have to identify Lewis acid. Yes, you try to answer 12th question. Very good, Sriram. Abhilash, check your answer. I am not asking to identify an acid, but you have to identify a Lewis acid. Lewis acid. No, Sahiti. At once check your answer. You have to identify Lewis acid. Aditya, very good. Electron deficient compounds will act as Lewis acid. So option C, ferric chloride is the electron deficient compound. Rajeshwari, very good. So that will act as a Lewis acid. Moving to the 13th question. Which of the following is a Lewis base? Identify which of the following is a Lewis base. Lewis base. Which of the following is a Lewis base? Very good. Tilak. Sujit, very good. Remaining students are also supposed to answer. Sriram, check your answer. You better identify Lewis base. Lewis base means it is capable of donating the electrons. Very good, Swati, Kiran Babu, Abhilash, Sahiti. Swati, why you are giving two options? Okay. Option A, nucleophile. Nucleophile means electron rich species which carries negative charge. So it can donate a pair of electrons and will act as a Lewis base. Let us move on to the 14th question. An ether is. Rajeshwari, very good. You try to answer 14th question. An ether is. Okay, I will give a small hint. I will write the structure of the ether. C2H5O, C2H5. Now identify. An ether is a Lewis acid, Bronsted acid, Lewis base or Arrhenius acid. Very good, Kiran Babu. Abhilash, Tilak, very good. Banu, check your answer. At once check the structure. Sujit, very good. You check the structure I have mentioned. Sriram, very good. Very good, Swati. Very good. So, here again oxygen is present. So, it is capable of donating electrons. So, it will act as a Lewis base. Next, amines behave as. Coming to the last question, that is 15th question. Amines behave as. Do you know the structure of amine? I will give the structure of amines. Now identify what is the behavior of amines. Amines. Check your answer. Kiran, very good. Sriram, check your answer. Amines. RNH2. RNH2. Yes. Tilak, very good. Very good. So, whenever nitrogen atom is present, it is capable of donating a pair of electrons. Very good, Sujit. Rajeshwari. So, amines also will act as Lewis bases. That is enough for today. This is all about the Lewis theory of acids and bases and the multiple choice questions based upon the Lewis acids and bases. Very good for your participation in this live class. Good night.